Now, whenever there is a normal distribution question in exams, quite often one of the things that they would like to test students is the sum and differences of two normal independent random variables. Okay? Now, what this means is if I have x and I have y and they are independent normal random variables, then you need to know that ax plus by, where a and b are constants, will always be a normal distribution. Okay, and then you need to know what will be the new mean and the new variance of this distribution. Now, to do this, let's begin by looking at a simple case. I'm interested to look at the distribution of ax plus b. Alright, now for any random variable x and any real number a and b, the expectation of ax plus b is always aex plus b, and the variance of ax plus b is always the same as a squared times variance x. Okay, these are two rules that you can use all the time, irregardless of what your distribution of x is. Now, if I have x and x follows a normal distribution with mean, mu, and variance sigma square, then ax plus b is always going to be normal. Okay, and it's going to be normal with this mean and this variance. Now, let me show you how to get all these values. So first of all, we look at expectation of ax plus b. Now, from the formula here, you know that this is the same as a e x plus b. But what is expectation of x? Expectation of x is mu. So you get a mu plus b. There you go, a mu plus b. Now the next thing I want to find is variance. Okay, so what is variance? Ax plus b. Now this is the same as, according to your formula here, a square variance x. And what is your variance of x? Sigma square. Okay, sigma square. Okay, so whenever you have a normal distribution x, then any distribution that looks like this, ax plus b, will always be normal with this mean and this variance. Now, two things to note is the expectation of a constant is always a constant itself. Okay, the expectation of a constant is always the constant itself. Variance of a constant is always 0. In other words, if I have expectation of 1, this is always 1. If I have variance of 20, this is always 0. Okay? Now, let's take a look at another two rules. Now, if I have expectation of ax plus or minus by, this is the same as aex plus minus bey. The version for variance is variance ax plus by is the same as a square variance x plus b square variance y. Now, these two rules you can always use, okay, for any independent random variables x and y. Okay, and for any real constants a and b. So if that's the case, okay, we have some more formulas for you to remember. Now, when I have two independent random variables x and y, then if I know that x follows a normal distribution with mean mu1, variance sigma 1 square, and y follows a normal distribution with mean mu2 and variance 2 square, or rather sigma 2 square, then x plus y, x minus y, or in the more general form, ax plus by, ax minus by, they are all normal distributions. And they are all normal distributions whereby you can easily work out the new mean and the new variance. Okay, now I will show you one example. The rest you can do it on your own. Now let's say we want to look at part 3, okay, or rather this equation in the box that you see, and then I know that ax plus b, as long as your x and y are independent normal random variables, then the end product is still going to be normal. So I want to figure out what this is and what this is. Now this lot here is actually the expectation or the mean of this number. or rather this random variable. And this will give me, remember, I can first split both of them up. Then I can take the constants out. So this becomes AEX plus BEY. And what is AEX? EX is mu1. And then what is EY? EY is mu2. So this gives you this. Okay? Now let's take a look at the variance. Let me erase this. Okay, now I want to find what this number is. Now the variance of AX plus BY. Okay, let's do it step by step again. I'm going to split them. Then I'm going to take the A out and the B out. Okay, then I will get A square variance X plus variance, take out B, become B square Y. And what is variance X? A square sigma 1 square, and then B square sigma 2 square. Done. Now the version for minus is a little bit more tricky. Let me show you how to find the variance of AX minus BY. Okay, so let me again erase this. Let's do it step by step again. Variance AX. Now I will put a plus here, and I will put a minus BY here. Okay, everything is still the same, no change. Then I'll take my A out. Now for the first one, A comes out and becomes A square. For the second one, I'm going to take out minus B. So you have minus B whole thing square, variance of Y. And then I have A square sigma 1 square plus B square. See, the minus has disappeared. Variance, sorry, this should be sigma 2 square. There you see, it's a plus and not a minus.